Usually, if it's a talking squid video, I wrote a script. I didn't write a script, I'm just freestyling this one. This is a Pokemon. Specifically, it's a Bulbasaur. I like this guy. I have hundreds of these pictures, one for every Pokemon up to generation whatever. Each one of these Pokemon pictures is a 64 by 64 image with 3 channels, red, green, and blue. And I love these. They're adorable, and I want to make more of them. Specifically, I want to make a generative adversarial network make more of them. It's a neural network which makes images, tries to see if it can tell the difference between its own images and real images, and uses that information to make better pictures. Nowadays, stable diffusion is the way to do this sort of thing, but that's a video for another time. My generative adversarial networks in the past, the GANs, my GANs, they were able to make pretty good pictures of numbers, and okay pictures of faces. But, numbers and faces, they have patterns to them. Pokemon, they're all over the place. Look at these darn things. So a generative adversarial network, a GAN, it's not very good at making them. My Pokemon images aren't terribly good, so I like calling them Blorpomon. I like to describe them as clouds, where it's easy to see a Pokemon in that cloud. But what if we put the free energy principle in here? Let's find out. The free energy principle is an idea from information theory, derived from the Bayes theorem, that is supposed to describe how sentient beings operate, how the mind works. And the idea is that we want to minimize surprise. We want to minimize uncertainty. And the way you do that is by maximizing certainty, by exploring your environment until you understand it. So free energy, I don't like the name of it. It's not energy we're getting for free. It's energy which is available, maybe available energy. I like to call it wasted energy, because you want to use all this energy. You want to minimize wasted energy. So how can we put the free energy principle, the FEP, how do we put the FEP in a GAN? How can we FEPGAN? So I've written some code. You'll hear me clicking. I think you'll hear me click. Hear that? Hear that? So I don't think I've seen any academic papers about using the free energy principle in image generation, or text generation for that matter. And I feel like maybe that's something missing. So let's look over this code. By the way, I have all this code in a GitHub repository, so you can click on a link in the description, and I encourage you, go wild. Go wild on this thing, because GANs, they're so weird and hard to get everything working. A lot of the time, the discriminator is just going to be so good that the generator has no hope. The generator has no hope to fool the discriminator, and if you do that, we call it collapsing, because the generator starts making the same image no matter what kind of seeds you give it. Which is something that I'm hoping entropy and the free energy principle as a whole, maybe it can sort of combat that. First of all, I have a whole bunch of arguments. Generative adversarial networks, they're hard to work with because there are so many arguments that you need to customize to get what you want. Going down, I've got something to collect those pictures of Pokemon I've got. I have ways to arrange those pictures. I can make animations with the pictures we've made. I can plot the loss values of the generator and the discriminator. I'll try going over what that actually means. And I have my own little layer here, my layer of a neural network that uses a convolutional neural network and maybe attention, because there's a famous paper, Attention is All You Need, which sort of introduces this idea of an attention layer. And maybe I'm overcomplicating it, but that's what I do here. That's what I do here at Thinkster. So let's look at the generator. The generator is the part that makes images. It starts out with a random seed, just like a whole bunch of random numbers, and it uses that to make something which is, let's say, 32 by 4 by 4. So the generator takes that 32 by 4 by 4 collection of numbers and makes them into a square shape, which is 4 by 4 with 32 channels. Now I'm actually adding another 2 channels. I'm adding something for position. So the neural network should have some kind of idea about where in the image it's working, like in the top left, in the bottom right. And we're going to feed that through a couple of my layers, the ones which have convolutional neural networks, so they can sort of survey the entire image, and attention layers, which means that it can sort of go over the entire image in a global manner, so that if it looks at one part of the image, it's also considering all the other parts of the image. And for each one of these layers, I'm growing the picture. I'm growing it. So instead of being 4 by 4, it's going to be 8 by 8. And then instead of 8 by 8, it's going to be 16 by 16 and 32 by 32. But here is where I'm going to try adding the free energy principle. One of the places I'm trying to add the free energy principle. Instead of just having the generator continue going up to 64 by 64, I'm having 2 of my layers, which together produce a probability distribution. We have mu, meaning mean, average, and we have STD, meaning standard deviation. So the idea is that we take this mean and we take this standard deviation and we sample from it. And we're going to use that sample to continue the process, where we're going to use something sampled from probability distribution to continue growing these Blorpomon pictures. Oh, and for the mean and standard deviation, I do the positions again, just so it knows where in the picture it is. So we're going to make them 64 by 64, and we're going to have one last convolutional neural network, leave them as 64 by 64 with only 3 channels, red, green, and blue. So that's going to be how we're making these pictures, with this entropy step about halfway through. The discriminator, I'm making it a bit more complicated than it needs to be, because you know me. The discriminator, it's not going to just get a batch of pictures. It's also going to get a whole bunch of statistics about those pictures, like the quantiles, how much green is in here, how much red is supposed to be in here, and it'll use those to compare the statistics of the real pictures we give it and the fake pictures that the generator generated. So I'm going to do stuff with those statistics, I'm going to do stuff with the images, I'm going to put them together, and then I'm going to put them through a couple of my layers, and instead of growing the image, it shrinks the image. So they're going to be 64 by 64, then 32 by 32, then 16 by 16, then 8 by 8, and then 4 by 4. And then we're going to flatten that, which is going to be 32 times 4 numbers. We're going to use one linear layer, which is going to make that a bit smaller, and then we're going to have the discriminator have its own probability distribution here. It's going to have a mean and a standard deviation. And that's, I think, a big part of the free energy principle here, is that the discriminator has an option to say, I'm not sure about this. Maybe it is, maybe it isn't, I'm not sure, which means I can have a wider probability distribution. Or maybe it says, I am sure. I'm pretty sure of my answer. Which means it can have a very narrow probability distribution. And then finally, we're going to use the sampled value from that mean and standard deviation, and we're going to make a final answer. It's just one number between 0 and 1, and it's saying, I'm this confident that it's a real Pokemon, or I'm this confident that it's actually just a Blorpomon. So I've got another class over here. I just call it a GAN, and in each epoch, we're going to train the discriminator first, and then the generator. So the generator, for the sake of the discriminator's training, is going to make a whole bunch of Blorpomon. And we're also going to sample a whole bunch of real Pokemon pictures. And just to make things a little bit harder on the discriminator, we're going to make it so some of the real Pokemon are actually labeled as fake, and some of the Blorpomon are actually labeled as real. That gives the generator a chance to just sort of poke its way through and try to fool this discriminator. I actually make it so you can have multiple discriminators, because sometimes it's good to give the generator, like, you failed for these reasons and also these reasons. So we're going to have the discriminator assess the Blorpomon, and we're going to have the discriminator assess the real pictures. And we're going to take both of its loss values and combine them. So we have a big a batch of information, which is what the discriminator got correct and wrong and why it did it. It's not just trying to make accurate predictions, it also wants to minimize complexity. which means it wants to sort of minimize its uncertainty. So the discriminator wants to minimize complexity, which means it actually wants that standard deviation pretty low. It wants a lowish standard deviation. But combining those ideas, combining how correct it is about things and how low its complexity is, the discriminator is minimizing free energy. It wants high accuracy and low complexity. But now we're also going to train the generator. And so the generator, it's going to make a whole bunch of new Blorpomon. And for all the discriminators, we're going to have the discriminators assess, what are these? Are these Blorpomon? Are these real Pokemon? And so we're going to collect that. The generator wants to maximize that. But also, the generator gets an entropy value, and it wants to maximize entropy, which means it wants to have high standard deviations in its neural network. And not only that, but it gets a curiosity value. So curiosity means it's not just trying to act randomly on its own, it also wants the discriminator to be so uncertain that the discriminator has to use high standard deviations. So the generator, it actually wants to maximize complexity. It's as if the generator wants to maximize free energy. So now these two neural networks are competing, they're adversarial, in two different ways. The discriminator wants to be good at discriminating between Blorpomon and real Pokemon, but it also wants to minimize free energy. And meanwhile, the generator over here, he wants to make a good Blorpomon, but he also wants to maximize free energy by shaking the discriminator's world and making it confused and uncertain about stuff. So this is sort of a lot like the ducks I made explore a maze in that other video about a paper I published. By the way, I published a paper, where the ducks, on one hand, they want to maximize rewards. They want to collect rewards by exploring this maze. But also, a part of it wants to minimize free energy. It wants to be able to predict what it's going to see all the time. And it doesn't want new information to completely confuse it. But another part of the duck says, well, I've done this stuff before, and I don't like the rewards I'm getting. The rewards that I'm getting are low, and I'm getting bored. So let's try confusing ourselves. And so it'll have adversarial relationships with themselves, where they want to minimize free energy, but when they do, they get bored, so then they try maximizing it again. So I ran a bunch of tests about this. Again, you gotta really fine-tune these hyperparameters. It's basically impossible to do this perfectly. But here we can see, okay, this is one I made with hyperparameters which don't reward the generator for entropy or curiosity. The discriminator wants to maximize accuracy and minimize complexity, but the generator doesn't care about making random decisions, and it's not interested in surprising the discriminator. And so we can see we're starting here. This is before any kind of training has started. This is just the values we get from a lot of different seeds. And then if we go from the beginning of training to the end of training, using the same seed, we can see this is how the generator started. And down here, that's vaguely Pokemon shaped. It's vaguely Pokemon shaped, but then it collapsed. It just doesn't look like anything. And if we look here at the loss values, it's not doing terribly well. So this line represents how well the generator is doing. The generator wants this line to be low. It wants low loss value. But you can actually see the collapse right here. Yeah, you can see it's having a lot of trouble. It's just stuck right here from this point to the end of the training period. And this line here is always at 0, and that's because it doesn't care about entropy, and it doesn't care about curiosity. Meanwhile, over here, the discriminator is doing pretty darn good. It looks like its loss values related to the actual Pokemon and its loss values related to Blorpomon, they're going down. It's pretty accurate at discriminating between them. Over here, we can actually see the rate at which the discriminator correctly or incorrectly classified different pictures. So maybe it's this accurate at diagnosing Blorpomon, and it's this accurate at saying that's definitely a real one. Down here, this is the mean and standard deviation from that probability distribution which the generator was using. And after the collapse, the standard deviation just plummets. It doesn't care about having high standard deviation. It just put the standard deviation here and it's fine with it. And the discriminator over here, we can see its mean and standard deviation too, and the standard deviations are usually the same for Blorpomon and real pictures. Now let's do it with some encouragement of entropy. So we're telling the generator, don't just try to fool the discriminator. Also, try making randomness, high standard deviation. So if we actually look, I think this is really interesting, if we look at the standard deviation made by the generator, sometimes the standard deviation is kind of level, but every once in a while it spikes. And I think the way to interpret this is that sometimes the generator thinks it knows what it's doing, but sometimes the generator says, that discriminator, it's overpowering me. Which means instead of aiming to minimize my losses, I can actually try maximizing standard deviation instead. And by doing that, it makes weird random Blorpomon, which, in theory, might be better at fooling the discriminator. So it finds ways to fool the discriminator by using randomness. And so here are the loss values here. You can see this one is for entropy. And it looks like it's just 0 the entire time, but even small changes can make a big difference. So here are some Blorpomon from beginning of training to end of training. If we look at this animation at the end, I think those look pretty good. Not terrible. But now, let's try adding curiosity. The generator doesn't just want to fool the discriminator, and it doesn't just want to act randomly. It also wants the discriminator to be surprised. The generator wants to fool the discriminator with its Blorpomon, and it wants to act randomly, but it also wants its Blorpomon to make the discriminator's standard deviation go up. Meaning that the discriminator says, I don't know. This could be a Blorpomon, this could be a real Pokemon. I don't have a clue. And so if we look at this standard deviation and mean from the generator again, it's trying to get more standard deviation sometimes to make random Pokemon when it thinks it can't fool the discriminator. But we can also see the standard deviations of the discriminator for Blorpomon are ever so slightly higher than those for real pictures. Meaning that this discriminator, it's trying to keep these standard deviations at a minimum, but every once in a while, if the generator doesn't know what it's supposed to be doing, it can instead say, let's try surprising it. How does this work? Is this going to work? Can the generator make better Blorpomon? Well, I'll tell you, I'm actually recording this audio before I see all the results that I want to put up, so I'll leave this up to you. Alright, I'm going to pretend that looks really good. I'm just going to say, wow, oh, the free energy principle, everybody. Let's do it. Is this art? Is it art? Well, I'd say the GAN, the Generative Adversarial Network, that's art. That's my art. You know, and this YouTube video, that's my art. Ooh. But is it art when I generate it? Are these Blorpomon art? Well, I guess they're kind of like modern abstract art a bit. But I guess it really makes you ask, what is art? And, you know, I'm the kind of pretentious squid who says everything is art. But I'll also say, if the only art you make is generated by an AI, then I think your soul is boring. I think you have a boring soul. Make art. And maybe the free energy principle, well, maybe eventually it'll make artificial intelligences have curiosities and creativities which can put us squidlings to shame. Let's find out. Bye-bye. If you feel like it, throw money at me.